Okay guys, welcome to our next lesson. Today we are going to be doing section 4.3, day 5 and day 6. Okay, still on logarithmic functions, so mostly a lot of examples in this PowerPoint, and we're going to go through them quickly. These are the last lessons before the quiz. Okay, so after this, we're just going to have several days of quiz review, and then we are having the quiz to follow this up. So let's get started. Properties of log functions. We've done this in the past, but it's been a while, and these properties are so important as we get into solving these logarithmic equations. So keep in mind that the log of 1, regardless what the base is going to be, is always going to be 0. So my first property, whenever you take the log of 1, it is always 0, no matter what the base is. So if you do log base 6 of 1, you get 0, okay? Of course, our only exception is if the base is 1. For my second property, if you have the same base and the same number, log base b of b, then you always end up with 1, okay? Because the base and the number, in essence, cancel each other out, and so that's why we're left with 1. For my third property, if I have log base b of b to the x, again, just like property 2, the log base b and the b cancel each other out, and we're just left with x. So for my fourth property, b to the power of log b x, again, my log base b and my b cancel out, I'm just left with x. For my fifth property, if log base b of m equals log base b of n, then notice again, the log b on the left cancels out the log b on the right of the equal sign, so m equals n. For property number 6, log base b of m times n. Remember, there's an invisible multiplication going on between those two numbers. And so how we can break these apart is log base b of m plus log base b of n. So if you have the log of two values being multiplied, you can break them apart with that plus sign, with that addition. Now let's look at property number 7. Log base b of m divided by n. So property number 7 is pretty much the opposite of property number 6. In property number 6, the values were being multiplied, so we split it up with addition. In property number 7, the values are being divided, so we're going to split it up with subtraction. It would be log base b of m minus log base b of n. Okay, so if you have two values being divided, you can change that into subtraction. And for my final property, log base b of m to the power of p, when you have an exponent here, what you can do is put it in front of the log as multiplication. So this would be rewritten as p times log base b of m. And we'll see here through the different examples how these different properties come into play with solving. But please save this slide, guys, fill it out on your own, or just make sure you're going back to it as we go through the homework. So here's our first example. Rewrite in terms of log x and log y. So that means that you want log x all by itself, log y all by itself. Notice they must be separate logs. So if we are dividing, remember, we can separate these logs with subtraction. That was my property number 7. So how I'm going to separate these is log x minus log y. And that's it. That's my final answer. Because what's my invisible base here? My invisible base is 10. So my invisible base here would be 10 as well. Okay? But the final answer that you're going to see is just log x minus log y. My next example, rewrite in terms of log x and log y. And again, they must be separate logs. All right? So notice my terms here are being multiplied. So this is property number 6. If I have terms that are being multiplied, I can separate them with addition. So I'm going to separate them into log x to the 4th plus log y cubed. Now, this is not my final answer because I do not have log x alone and log y alone. When we say alone, it means we can't even have these exponents here. So what can we do with those exponents? This goes to property number 8. Okay, so property number 8. I can take this exponent and move it out in front as multiplication. So I would have 4 times log x plus, let's take that 3 and move it out in front, 3 times log y, and this would be my final answer because notice now log x is all by itself and log y is all by itself. Okay, guys? And that is the kind of answer they're going to be looking for on the quiz and test. So make sure you move those exponents out in front. All right, our next example. Rewrite the expression as a single log. So now we are doing the opposite. We're going to combine these two logs into one. So when we see ln, we should know that we are really working in base E. It doesn't affect the problem necessarily. I just want you guys to be aware of that. And if we are subtracting, we can combine with division. Okay, so I would just do ln of x over y. That's it. And there's my final answer. ln of x over y. All right, here's another one. Rewrite the expression as a single log. So don't get overwhelmed, guys. Just deal with the first part first. So let's deal with this first. But before I start combining, what do I notice about this 2 and this 5? This goes back to property 8. If I have these in front, I need to make that 2 an exponent, and I need to make that 5 an exponent. So I really have ln of x squared plus ln of y to the power of 5 minus ln z. So that's really what I'm working with. Okay, guys? Use those properties and apply the rules. Now, let's combine my first two terms. Then I can worry about the third one. If these first two are being added, then remember addition can combine into multiplication. So I'm going to have ln of x squared times y to the power of 5. So I just rewrote them as multiplication. My minus ln z is still here. Now let's do my last step. If I have subtraction, okay, then how can I combine my logs? To combine them with subtraction, it's going to become division. So I'm going to divide x squared y to the 5th by z. So I'll have ln x squared y to the power of 5 divided by c. And there is my final answer. Okay, guys? So we took this entire original problem and we combined it into one single log. Here is my next example. Given that log x equals -2 and log y equals 3, find the log of the square root of x divided by y cubed. So the first thing we want to do is separate these. We want to get log x alone and log y alone. So if I have division, I can separate these with subtraction. So I end up with log square root of x minus log y cubed. Now again, in college algebra, it is expected of you guys to know just basic mathematical properties. A square root is the same thing as saying to the power of 1/2. So all I did was rewrite that, but we need to be aware of those properties. So instead of log square root of x, I'm going to write log x to the 1/2 minus log y cubed. Now, my log x and log y aren't totally alone, so go back to property 8 in our properties of logs. I'm going to take this exponent, move it to the front, take this exponent, move it to the front. So now I have 1/2 times log x minus 3 times log y. Now that I have my log x and my log y totally alone, I can plug in these values that I was given in the original problem. Because in the original problem, I'm told that log x equals -2. So instead of log x, I'm going to plug in -2. And I'm told that log y equals 3. So instead of log y, I'm going to put 3. Everything else gets carried down. So my 1/2 times -2 minus 3 times 3. So here I'm just going to simplify. 1/2 times -2 is -1 minus 3 times 3 is 9. Make sure you follow your order of operations, right? Do all the multiplication first. And then -1 minus 9 gives me a final answer of -10. Okay, guys? So there we go for this example. Final answer is -10. So let's go to day 6. Again, we're going to go through just a lot of examples here quickly. All right, guys? With a little bit of graphing log, make sure you guys have your calculators out. Keep in mind that the parent function is going to be f of x, right, equals log of x. That's just our original parent function. Now, when we say log of x, our other option would be ln x, because these are our common logs and then our natural logs. Remember, the common log is default base 10, and then the natural log is default base e. Okay, so those are the two parent functions, log x, ln x. A vertical translation means that you are moving up or down, so you are adding and subtracting outside the parentheses. A horizontal translation means you're moving left or right, so you are adding or subtracting inside the parentheses. And keep in mind that horizontal translations are always the opposite. So if you see +3 on the inside of those parentheses, you are actually going to the left 3. Okay? So my horizontal translations are always the opposite of what you think they would be. And then a reflection is going to be when you multiply by a negative number. So whenever you multiply by a negative number, you are reflecting. Notice it has to be multiplication. So it's not just because you're subtracting. You have to be multiplying by a negative number. So let's look at the example here. What transformations occur? So first thing, this -4 is not being multiplied. This is just being subtracted. And if it's being subtracted outside of parentheses, that means that we are doing a vertical translation down 4. Okay, that's it. Now, if I have my -1 inside parentheses, I'm subtracting. It's the opposite, so I'm really going to go right 1. So that would be my answer. Okay, guys, my final answer for what transformations occur, it's a vertical translation down 4 and a horizontal translation to the right 1. All right, a little bit more here with graphing. The graph of a log, okay, is here in this example, the one that we've given you. It is decreasing as it approaches infinity. Remember, infinity refers to the x-axis going to the right, okay? So as this graph is going right, it is decreasing. We see it trending down, okay? This second graph that we gave you, the graph is actually increasing as it approaches infinity. Remember, infinity just means as we go right on the x-axis. And you see here, as we're going right, this graph is trending up. When we ask you for the domain is always what x can be. We are going to be using interval notation, so keep that in mind. Okay, so remember interval notation, you would tell me like 2 to infinity, that kind of thing. A vertical asymptote, any asymptote, is always a line that the graph approaches but never touches. Okay, guys? So keep in mind some of those asymptotes. For example, here, you see this asymptote, right, at x equals 0 because that graph is approaching it but never touching. Same thing here, at x equals 0, the graph is approaching it but never crossing it. All right? So let's keep going here and do our first example. So for my first example, use transformations to explain how the graph of g is related to the graph of the given function f. Determine whether g is increasing or decreasing. Find the domain and the vertical asymptote. Sketch the graph of g. So notice, I have graphed both of these in the calculator. But be very specific about which one is which, okay? Notice I matched them up by color. So here's my original log base 1/3 of x. And then here is my new function g, log base 1/3 of x minus 2. So if my original is this red graph and my new function g is the blue graph, what transformation has taken place? You can look at the equation itself, and you can also look at the graph. Notice this point at 1, 0 has now become, in my new graph, 3, 0. So what happened to the graph? It went to the right 2. So that would be my transformation. And notice you can also see it in the equation. If I have x minus 2 in parentheses, that means I went to the right 2. For my increase or decrease, remember, this is all in relation to graph G. So is graph G increasing or decreasing as I go to infinity? This is decreasing. So you would tell me decreasing. The domain, this is where it gets tricky. What is the domain of graph G? Remember, domain is in relation to the x-axis. So where on the x-axis can this graph travel? And notice, this graph never goes past 2 on the x-axis, okay? And since that is an asymptote, that means I'm going to write my domain as 2. Then if we're going to the right on this x-axis, does my graph of G have any limits? No. So I'm just going to put infinity. Okay? So my domain is 2 to infinity for graph G because I can go anywhere from 2 and then as far right as I want to be. My vertical asymptote is also x equals 2 because as you see in purple, that's where my line is that the graph approaches but never crosses. Let's do another one because I know this is a little confusing. So my next example here with graphs. Use transformations to explain how the graph of G is related to the given graph of the log function f. Determine whether G is increasing or decreasing. Find the domain and the vertical asymptote. So here's my original that I've graphed in red. Here's my new function G that I've graphed in blue. And so let me make sure I get all of it in there. My new function G that I've graphed here in blue. Okay, so here's G. And then I have my original function f there. So let's see the transformation. If f is my original, what has happened with G? Okay, so I think an obvious is that it's been reflected. Okay, so we would say reflected over the x-axis, right? Here's my x-axis, and it has been flipped over that x-axis. And notice, why did that take place? Because of that negative. Whenever there's a negative that's being multiplied, it's going to reflect. And then what's the other thing that it's done? It's not only reflected, but this -1 means that we also went down 1. So there were two transformations that took place. reflected over the x-axis, and the graph moved down 1. Now for increasing or decreasing, remember we're referencing G. So look at my graph G. Is it increasing or decreasing? You would tell me it is decreasing as we go towards infinity. For the domain, again, domain of G. So G can pretty much go wherever it wants to the right, but over here, it cannot cross this invisible 0. So my domain would be 0, infinity. So there's my domain for G, and my vertical asymptote would be at x equals 0, because that's that purple line that the graph approaches but never crosses. Let's look at my next piece here, guys, which is going to be inverse logs, and this is really my last piece. We're just going to do the notes on it and then the example. Inverse notation is always going to be f to the negative 1. So keep that in mind, because sometimes in the directions, they won't tell you to find the inverse. They'll just say find f negative 1. So you need to know that's the inverse. Keep in mind f of x is just another way of writing the letter y. So to find the inverse, we switch x and y, and we solve for y. Okay? So let's do our examples here. So my first one. Find f negative 1. So notice the directions don't say to find the inverse. You have to know that f negative 1 is the inverse. So let's rewrite this using y. Instead of f of x, I'm going to put y equals log base 5 of x. Now I'm going to switch x and y. So I'm going to have x equals log base 5 of y. Okay? Now, this last step, again, you need to know to take this step in order to solve. So I'm going to rewrite this logarithmic form into exponential form. So my base is always going to be my base. The number by itself on the other side of the equal sign is going to be my exponent. So 5 to the power of x equals, and then whatever we're taking the log of goes alone on the other side of the equal sign. And there we go. I have gotten my inverse because y equals 5 to the power of x. My last example, guys, this one's going to be a little bit tricky, but let's follow our steps. Find the inverse. Step 1 is to rewrite using y. Y equals 4 log base 3 of x plus 3. Step 2 is to switch x and y. X equals 4 times log base 3 of y plus 3. My next step is to rewrite in exponential form. Okay? Now, before we do that, keep in mind, this 4 times log base 3, I'm going to move this to my exponent. Okay? So I'm really going to have x equals log base 3 of y plus 3 to the power of 4. So now I don't have that 4 in the way when I rewrite this in exponential form. So to rewrite this in exponential form, my 3 stays as my base. Whatever number is over here becomes the exponent. 3 to the power of x equals, and then this whole expression is what we're going to equal. Equals y plus 3 to the power of 4. So now I've rewritten this in exponential form. My next step is to get rid of the exponent. So I want to get rid of this 4. So in order to get rid of this 4, how can I do that? If I just want my exponent to be 1, I can divide by 4. Because then the 4 and the divide by 4 would cancel out. But if you do it to the right side of the equation, you have to do it to the left side of the equation. So to get rid of the exponent, I now have 3 to the power of x divided by 4 equals y plus 3. Because here on the right, they cancel out. And so my last step, guys, to get y alone is just subtracting this 3. They cross out. So my final answer is going to be y equals 3 to the power of x divided by 4 minus 3. And that would be my final inverse answer here in the bottom right. Okay? And I know this one was a little bit tricky. You'll have one on your homework to have some practice with that as well. Okay, guys? So here is your homework. Make sure in Google Classroom you go into the correct section for 4-3-day 5. Notice it's only a few problems, 80 to 90 even. For 4-3-day 6, again, only a few problems, 92 to 102 even. Upload the photos of your work into Google Classroom. And like I was saying, this is it. We have no more lessons prior to the quiz. Quiz is on Tuesday, April 14th. Okay, and then the quiz review is already up in Google Classroom for you guys to get started. So thanks, guys, for joining me for